Are we ready? We're ready. I'm ready. We're ready. All right, so let's get started. So this is a continuation of the last weekend that we had 2 weeks ago. And I just had to refresh my memory a little bit, but it looks like we stopped on Lecture 5, Interface Design, that went over interfaces and cloning and a few miscellaneous topics as well. So today we're going to cover the concept of collections, which is going to be our links, our linked lists, our lists, our queues, our stacks, and all of the built-in functionality. And you'll see how easy it is in Java compared to C++. We will cover exceptions and input-output, and we're probably going to get to use our interface design components with Swing today. I'm not going to cover network programming. I'm not going to cover threads. Instead, I'm going to supplement with some more examples and focus more on the assignments. Note to self, the assignment number 4 that is on the schedule is optional. It counts as extra credit if you do it, but you don't have to do it. I've decided, well actually last time I taught this course I also did the same thing with it. It's a bit hard. It takes an application, turns it into an applet. It's a bit more complicated than it probably should be. And I didn't rewrite the assignment. So I'm going to give you guys the same options I did the last time I taught this course, where if you do it, it counts as extra credit for 5 points. If you don't do it, then you don't have to worry about it. So you really only have to do assignments 1, 2, and 3 for this course. And we're going to go over, by the end of the weekend, we'll be going over, probably not till tomorrow, I'll hit Swing in assignment number 3. And assignment number 2, we're going to hit today. In fact, I'm going to do it right now. I'll start out with assignment number 2. Because I think I left off talking about assignment number 2. But yeah, if you've done it already, you get 5 points extra credit. If you haven't done it and you look at it, you take a look at it, you'll go, oh my, it's too much work for 5 points. It's way too much work for 5 points. And it's kind of tricky and not such a good deal on assignment number 4. Excuse me, I'm sorry, I'm talking about assignment number 5, not assignment number 4. Assignment number 5 is the one I'm talking about. Assignment number 4 deals with collections and stuff. That we will have to do. I didn't scroll down long enough here. So it's the very last, you only have 4 assignments to do for the course. The very last one, the 5th one, is optional. If you have done it or want to tackle it, it's not a bad exercise, but it's a lot of work. And so we'll cut this out into 2 days like we did last weekend. Get out about, I don't know, 3, 4-ish, 3-ish. We'll take a vote after lunch, we'll see. It depends on how fast I talk. So I've had my coffee, so I'm getting ready to talk fast. So I'm good to go. Any questions before we continue? Last class session, I introduced the midterm, told you about it, but it's nice to revisit the concept. It is a take-home exam. And it is available at bhacker.com, and it is, oops, let's get organized here. Hello, there it is. Yeah, I'm just refreshing everybody's memory. It's right here. It's not due till the very last day of the course, which is supposed to be the last weekend in October, but it's really the last day of the semester, is what I'm using as the deadline on that. And the LMS has not been set up yet, so you can't turn anything in even if you wanted to. There's no way of turning anything in right now. So stay tuned for messages from your TA to announce when the LMS is ready for you to submit assignments. You have to build the class and then build the, I think the classes are probably built, but the assignments aren't in there. Yeah, but like the new version of anything.
I think by this weekend it will be ready.
Oh, really? Okay.
Yeah.
Well, that was very overly optimistic. I won't hold my breath waiting on that one, but we'll see. I think by the end of October, it might be able to submit something, hopefully. Any other questions before I continue? And the same thing is true for the CSLO as well. Nope. If there aren't any more questions, I'm going to push straight through, full speed ahead. Last time we were here, just refresh our memory, so there'll be a little overlap in the beginning here just to get everybody back into object-oriented programming in Java mode. So, or get me back in there too. What have we got here? Object-oriented programming in Java, assignment number 2, it deals with inheritance. If you remember last time we talked about classes and extending classes from classes. This assignment I actually have out in my Eclipse program that it's not fully completely done, it's partly done. If you want, there's a nice little video out here actually in the assignment link area. this how-to video for assignment number 2 is going to be extremely helpful. If you want to take the challenge and do it without watching the video, I highly recommend doing that. And then watch the video after you've already taken a try at it, and then because it gives too much away. So at least you'll have an opportunity to see if you can do it on your own before the video. And then the video is going to help you do it, essentially. So there's no excuses on assignment number 2. That one is pretty much done for you. Assignment number 1 is pretty good too. That one's pretty easy as well. So assignment number 3 is a little bit more complicated. We'll talk about that by the end of today. It's not that much more complicated. It gets into the concept of collections. So assignment number 2, IT wants you to write some classes for the personal record system. And what we're looking at is building a hierarchy of 4 classes, 1, 2, 3, 4, and person, employee, instructor, and student. And the following figure illustrates the relationship between the 4 classes. So person, and then we extend from person to employee, and we extend a student from person. An employee can be an instructor. We can also have an employee that's not an instructor. So we can have multiple things coming over here. But remembering from last time, it's really a single line. One class is extended from another class. And we use those interfaces so that we can interface multiple sets of implementations. So it actually kind of creates multi-line inheritance, in essence. But with true inheritance without interfaces, abstract classes or interfaces, what we're looking at essentially is a one-to-one. And there's a line that goes back. And then if you remember from last time, each one of the instructor objects is also an employee object, which is also a person object. So everybody's enclosed in here in terms of the inheritance. A little bit of a review just to get everybody back in the object-oriented thinking mode. And the assignment has you create the appropriate fields, appropriate methods. We know about those already. They're going to be necessary for the functionality. The person has an ID. The employee has a salary, obviously. A teacher has a teacher ID and a teacher name. Students, well, the instructor has a student array to keep track of all the students that are in the class. And then after everything is built, we're going to have a toString method to print the information to the screen. And then we also have a static method, so a class level method in here that's going to be able to find students, find teachers for students, so that students can be aware of teachers and teachers can be aware of students. And it's done at the class level, which is why it's indicated as being a static method. And if you remember the concept of static, we have static methods and we have static data members, and static essentially just says, instead of it at the instance for each individual object, instead of running the method there, we're going to run it from the class. And we're going to affect all instances of all objects that exist when we run this. So the person is supposed to be an abstract class because we're really not going to create any people. And if you have abstract classes, if you also remember, you cannot create instances of abstract classes. You can only use it for inheritance, essentially. And why you want to do that? Well, because a person is only going to have a first name and a last name, an age, stuff about people. We can still get at that information when we implement it in an inherited class. So abstract classes are sort of like empty classes as well, if you remember. They don't have any methods. Well, they have methods. They don't have any method bodies. They just have prototypes in them. And the rule with that, if you remember, is if you have one method or one piece of something in that class that's abstract, the entire class has to be declared as abstract. It doesn't mean everything has to be empty. You can actually implement stuff. You can have method bodies and actually fill stuff out in that abstract class and only leave one method empty, essentially, if you wanted to. What else we have going on here? Just the rest of the boring instructions here. There's a test.java class. There's a test.java, program that you can use to test it with, and that's what you need to test it with. So let's go out into Eclipse and take a look at this. And not to give you the whole thing away, but these are in the example files. This particular set is not given to you. This is what you need to create for the program. If you watch the video, you'll see it's practically given to you. So you can pause this video or pause the other one and write the source code down if you want, but that's kind of the cheating method. So just a review, and then this is my way of reviewing and also giving you some help on the assignment as well. When we're building hierarchies of classes, we always want to start with a base, actually. So you'd build a project and you would create the first class, which you can call it a base, you can call it a superclass. Superclasses are everything above, subclasses are everything below. A subclass can be a superclass can be a subclass. Everything comes from object, if we remember. So from object, we create a person, and the person has abstract, so it's public abstract class person. And this abstract class here has a static, which means it's going to be a class variable for maximum ID to set the IDs for each one of the people. And it's going to have its own ID, which is why we have two separate ones here. And we can't call them by the same name, actually. We have to use two different names. And then string name, unknown, I don't know. It's going to have a name, essentially. Could use a first name, last name, could just use a name. In this case, we just said name. So we can't really change the first name and last name without changing the name, but it's not really that big of a deal for this program. And if you remember, we have some constructors created. The one that does not take on parameters is the default constructor, and we have the default constructor person. And then we have person that's going to take on a string name. That's another constructor, and constructors aren't really considered methods. They're constructors, so there's a separation in logic. Because we can override, overload all of these actually, but when an instance of a class is created, only the constructors are fired. Constructors don't work after the instance is created. It's just done at the instantiation time, not accessible outside of that. And in here you might notice we're using this for this dot name, which means every person, and that this name belongs to the person class. Kind of standard to see people use this dot name, this dot date, this dot whatever the data member happens to be for the particular object we're dealing with. Because what ends up happening is further along the line you'll be working with an extended class and you'll be setting the name, and it won't be this. It'll be from person object, but you're setting it in student object or something. So, and I'll let you go through the code on your own actually, but the sets and the gets of the IDs and the names. And by default, just to review again, the main point being all of the data should be private and all of the member functions should be public. So we access the data from the member functions. So we're getting the name, getting the ID, setting the name, setting the ID. So, which is a big review from the first class. So what do we have here? This is just an ordinary class. We cannot make an instance of this object because it's abstract. So we're going to need to inherit. So let's take a look at student. And this is the word that creates inheritance for us, extends. And it's a lot easier in C++ actually. When we say class student extends person, we have private string teacher name, private integer teacher ID. So you want to get in the habit of doing this. The assignments are going to tell you, make this private, make that public. So. But you should probably know that by now anyway. So in here, we're not resetting anything that belongs to person. We're just using it. So in the constructor, and this is the default constructor, I just put it in here, but it's not really doing anything. But in this constructor here, and another thing to note actually, very good question. Nobody really even asked me ever, but excellent question, however, that usually comes up. Why put it in? You know, if it's empty, just leave it out. Why is it even in there? Abstract classes, every single method has to be implemented or appear, even if it's empty. If you leave it out, it's going to give you an error. The compiler is going to give you an error message and say, you have an unimplemented class. Uh-oh. So it has to appear, even though it's empty, it's in here, which is kind of senseless. So, I mean, it's just one of the rules. It's an abstract class. You have to implement. If you don't implement it, the abstract class isn't going to work properly. It's not going to have anything to invoke. So. And when you're implementing, you're either, if there's something written in the abstract class, you're overloading or overriding. If it's empty, you're doing the implementation. That's the first implementation. It's an overwrite. So it's kind of weird thinking, I think. I don't know. You get used to it and you go, it just becomes something that you'll just do, and then You know, well, there's logic to it, seriously. And then just to review a little bit here. Super says go back to person, the super class. Go back to the super class. Which is weird because we don't use sub. It'd be interesting if, if it said sub, super. No, super just says super back. Go back to the person class. And run the constructor that takes, it's an explicit invocation. It says run the constructor that takes student name. And in here we have one. It's right here, actually. It's person, but it's the same as student. It's the constructor. So this super is basically saying, explicitly run that constructor from person. And then this.teacher ID, this is all from this class up here. Which is, now you kind of probably see why people use this. This is like, just so you know, it's from this objects information. And then I'll let you go through the rest of it. I'll scroll through it for purposes of people who are cutting and pasting this, or cheating from watching this. But the toString method also needs to be implemented, and the toString method out in person is really not even in here, is it? toString? It's a bad example because oh, here it is. Public abstract string toString. This is the only thing that's abstract, actually. The rest of this stuff is an abstract. Well, we have one abstract method in this person class, and because we have one abstract method, we have to make the class abstract. If I took out this line, this prototype, I could take away the abstract part, and the thing would compile just fine, actually, and would run just fine. But this is essentially what's referred to as an abstract class. In C++, we'd call it a function prototype. It's a function is a method in C++, but we would say it's a method prototype, I guess, where we're going to say we have to include this, which means we're forced in employee to create this toString method. The toString method, if we don't implement it, we're going to get an error. You're probably wondering, well, then we can avoid the error by taking it out. So a lot of inexperienced programmers, they get rid of these error messages by removing the word abstract. And then removing abstract methods. And then you really have defeated the purpose, because you're avoiding the problem of having to implement something by taking away the restriction, by making it so that it will compile. But when you're compiling it and you're running it, you're losing functionality that should be there by the course designers. And that's kind of an interesting point as well, the philosophy of Java programmers. You put it in, you make it abstract, you have interfaces so that you can guarantee consistent functionality, consistent behavior, predictable behavior in terms of what it is you're looking for. Because going back to the building a hierarchy of classes and using these as foundation, these super classes are really the structure you're building on. And if the structure is weak, so will all the classes being built from it. So the concept is put a lot of restrictions in. Make a lot of abstract classes, enforce a lot of rules, and so that when people start building classes on these abstract classes and these interfaces in the future, they have to adhere by the rules, and we have consistency in the implementations, essentially. And the implementations are building what's called the public interface. The public interface is coming from our abstract methods. If we know we have an abstract method called toString here, and it's in every class that's inherited from person, and we know that, we can always run toString on everything. So we know that we already know the method name, we don't have to worry about it. So it gives us consistency, predictable behavior, enforces some rules. So outside of a student, we have the employee object. Kind of trivial, looks the same as the student really, just it's public class employee that extends person. And we know that down here we're going to have a toString as well. Here's our toString. Even if it's empty, we need to include it as that abstract class, going back to that. And the implementation is about the same. We have a super employee name. Alright, so super employee name here, set salary. These are all methods that we've implemented, essentially, for an employee. I don't want to show you too much of this because this is your assignment. And then we have an instructor. An instructor is an instance of an employee. So that's where we get instructor, which extends employee. And then in the instructor, we're keeping an array, and this is kind of interesting for new programmers, especially if you're starting to learn how to use arrays. We're creating a student array that is of the student type, but it's actually not really. It's essentially keeping track of 10 student objects, and the student objects are also people objects, so we can keep track of the IDs of those people, because every person just has a name. I guess students have student IDs, so we can keep track of them in the array. And an array of students is sort of the same as an array. In fact, this is just an array of integers. We're just calling it student array. But we could essentially create an array of anything. So if we have more objects, we can create an array of objects. We can create an array of integers, array of floats, doubles. Any data type can be used in an array structure. The instructions say that each instructor needs to keep a list of student IDs. IDs are integers, so we have a student array that are keeping track of the student IDs that belong to the teacher. The way we know that is because each one of the students has a teacher ID. So we use a, in fact, let me just go down here. This is the trick. This is the trickiest part of the entire program design. This has got the public static, which means it's not run from the method. It's not run from the instance of the object that's created. It's run from the class level. So out in main, which I'm going to show you in a few minutes, we're going to say instructor dot find students, and this is going to go out and essentially for all of the students, or for all of the objects that are people. Actually, we have a person array, so we have an array of people. For all of the objects that are people, find the people who are students. For all of the students, get their student IDs with the correlating teacher ID. And then for all of the teachers in the system, all the people who are teachers, get that list. Find out which students they've been, what their teacher ID is. And then in the student object, which is what this one is, put the teacher ID, so fill it in. It makes all the teachers aware of the students and all the students aware of the teachers. Populates both arrays. You can't do that on each instance. Instead, you just once or twice throughout the life of the program run a static method on the classes to clean things up. In our driver program for this particular application, it's being run at the end. So we make all the student objects, we make all the teacher objects. And then we have the students find the teachers find the students. So all the teachers know which students they belong to. Belong to in their classes, and then all the students know, the teacher IDs and stuff like that. Well, they already know that anyway, or they should know that. So, okay, so we have the main program. Let me just get to that actually, because we've got the employee, the instructor, who's an employee. We didn't get to. Here's the instructor, who's the employee. So it looks like we've gone through most of them. The main program, going back to what I was saying. We've got an array, and here's where we have an array of objects. Where the data type of the array is person. And you said, well, I thought you said we couldn't make abstract. We aren't. We can use it as a data type. We just can't make instances of these objects without making instances of these other objects. So we can make people instances. This person I said was an abstract class, and I said, oh, you can't make an instance of that class. But when you make a student, an employee, an instructor, you're making instances of that class, and implicitly. So we can actually use that as a data type, though, because person exists in the system. It's an abstract class. So we have a person array, and we have a maximum of, and it's a new person with a head count of, 25, 50, whatever. We have 20 here. So we're going to say, item number 0 is going to be new student Peter. And then we have an instructor. So we have a student named Peter and an instructor named Peter, which is kind of interesting. It tells us you need to use the student IDs in order to separate them. And we have a static maximum ID that we're keeping track of for all of the people. So each one of these people has a unique ID. So we don't really have to care about the name. And we have an instructor named Sandy and her salary. A janitor named Bob. We have a student, Tom, with instructor Peter, the teacher, not the student. And then we have a student named Maggie and her instructor Susan, instructor Susan and her salary. And then here's the static method call. This is the class level, the interesting part of this assignment. Filling in the array of the instructors to add students to their lists. So each one of the instructors has an array of students. And this instructor is the name of the class. And we're running the find students, and we're setting it the person array. And in the instructor class, here's our find students. That is of a static, so which means it's a class level, which means we can't say Bob or whatever the name of the object was, dot find students. We have to say instructor dot find students in order to run it. And this is the one that's going through the people array and assigning, figuring out, well, what teacher are you supposed to be assigned to, and then letting the teacher know, hey, here's a student, thinks he's assigned to you. And it's populating the teacher array with all the students who have that teacher ID. Are going to be using that teacher ID, essentially. And then correspondingly, I left this out of the code, actually, because I don't want to do the entire assignment for you. You have to find do the opposite. So this one here, if I were to uncomment it, would be filling in the array of the students to add the teachers and the IDs for their objects, which is the exact opposite of the students, of the instructor. And some system outs, and here's kind of like why we want to use the toString method here in that abstract class. We're going through an array of people, and we're printing out whatever the object happens to be, and this people array is holding instances of instructors, students, and employees. Actually, the janitor is in here too. And which is interesting is they all have two strings, so we can run them through a loop. Let's create an array of all these objects that are holding these multiple identities. Run them through a loop and still have consistently the same method that we can run to toString to print them out. And if it's a janitor, it's going to print out different information than if it's a student, than if it's a teacher, etc. and so forth. So if we run it, well, let's see if it runs actually. There's a Java application. Oops, let's see. Make this a little bigger. There we go, I get some nice output for us. This is the toString method that's running, the IDs and the names of the personnel in the array. So we see Peter's a student. That toString is printing out Peter's a student. Now Peter is also an employee with salary 0.0. So that's the toString method for an employee versus a student that's printing out the information. You can kind of see the same method call down here. That's what I'm trying to illustrate. This here is giving us, for all of the toString methods, different output. Because it's abstract in the person class, yet it's implemented because it's abstract. It's required to be implemented in each one of the classes that extends people. So all people have toString. All people have different roles in the system, so they have different stuff that prints out for them. So it's I like the this is your assignment number 2, by the way, for those of you who came in late. I like the assignment because it really does give you everything. Demonstrates inheritance. It doesn't do interfaces, but it does almost everything else. So inheritance, multiple different classes from inheritance, the concept of the abstract class, the reasons why we want to do certain things. So, questions about the second assignment? It's an abstract class. If I go to mainprogram.java, I never actually create any instances. I create an array that's of data type. Yeah, but I haven't put anybody in it. I haven't populated it. I can't go out. If I said, if I actually made a new person out of it, I know this looks like I'm making it, but I'm actually creating an empty array that's going to hold a maximum of 20 people. But I haven't said, it's kind of like saying you can say person, my person, and make an object reference to it. But if I said person, my person equals new person, without assigning this as a, let's say for example, an empty array holding 20, this is not initialized, it's just declared. If I initialize it, I'm going to get an error if it's an abstract class. As an example, let me just do it here. I'm supposed to, let's see, person, Oops, it's capital P. Did I spell that right? Can't instantiate a type person, so it's not even going to let me put it in. Instead, it's going to say, that's an abstract class. If I come back here, let's just do this real quick. Take away that abstract method. Get rid of this word abstract. Let's save it so you can, how do we save? Here we go, save. Go back here. Let's save this one too. Save. Now the error goes away, but it's going to tell me it's not remove person in all instances. Remove effect. It's an unused person. I'm not doing it. Here, if I go like this and go, what do we have? Person dot. Oh, my person. My person. Let me just run it so it's not. So we can see something. My person dot get ID. And we'll do a system out with this. Oops. This is why I always like to type stuff in ahead of time. Because I'm a terrible typer. Let's see, what did I do here? Capital P. No. Lowercase p. Yeah, so remember, all method calls are supposed to be lowercase. All classes are supposed to be uppercase. So, let's save it. Let me run it now. And now I'm going to get, maybe I should, you know what, I'm going to put this here. Just added. Alright, I just put this little text here so we can see it in the output, essentially. Now if I run it, it should work. Oops, we got an exception down here. Just added. Here's my just added one. So I did something. Actually, I do have an exception because I have a. I can't. The abstract. I've messed up the logic of the abstraction of the abstract method. So, but that's a side issue that I didn't continue to change because I removed the abstract part of it. But what we have now is just added, and we have one is the student ID that's coming out of person. So I was able to do, if I made this back here, if I go and I change this and make this abstract again, and I save it, then I'm going to get this issue here that I can't instantiate. And it's just a rule that's usually imposed by the Java, the JVM environment that just says, you're not supposed to do it. Would it work? Yeah, it will work. Can you make an instance? Can I do this? Yeah. That's going to be okay. Except for I used my person here. Good idea. Let's get rid of this. That's not going to give me an error message. Just the same what I'm doing here. I haven't populated that array. I haven't made any people object. I've just used the data type. What I've actually created was an array. And just the same way as I've created an object here that's going to hold a person, it's going to let me create that object. Excuse me, let me create that reference to the object. But I actually, until I actually create an instance of the object, it's going to let me do whatever I want to do. So, and in this particular case, these two lines are pretty doing the equivalent. We've created an array, but we haven't populated the array with anything. It's just an array of people. So it's a reference to an object versus an object, if you want to use that terminology. I don't like to say that, though, because every time I say the word reference, I always think about pointers. And then if I call it a variable, technically we have created a variable. Have we initialized it with any values? No. If I said integer, if I did the same thing with integers, we have it right up here, actually. Let's try instructor. Keeping track of 10 students in here. These are integers. I actually haven't added anything. It's just an empty array at that point. So until I start putting people in there, I haven't really created any instances of any objects. Which is the excellent point, excellent question, actually. And a source of confusion. You can certainly create variables of that type and references to objects of that type, but you can't create the actual object because it's abstract. So it's essentially, you could, theoretically, but the compiler's not going to let you because the compiler's going to say, well, what are you going to do with it? It doesn't have, abstract methods don't do any, abstract classes don't contain anything. In theory, they're not supposed to contain anything but prototypes. How are you going to run a method prototype? Why would you want to do it? Which is what the compiler says. Syntactically, there's nothing wrong with it, in my opinion. In fact, it's kind of an interesting phenomenon. I thought for sure that it would run. I thought for sure, but maybe Eclipse is doing it. It might actually compile. I'm not too lazy. I would go out into a terminal prompt and compile it. It would probably compile. It's the Eclipse environment that's preventing me with that error. But when I run it, I'm going to get a runtime exception. And it's going to say, abstract. This class is abstract. You can't create an instance of an abstract class. So this is essentially a buffer to the compiler. So it's going to catch it before the compiler even works. So, excellent question. Any other questions in this particular example? No. So that's your second assignment, which is pretty much done for you already. And if you missed any of that, you can watch the video, download the video. I'm going to fix that error real quick, though. What do we got going on here? Just get rid of this and this. There we go. Because the next time I bring this thing up, I have a tendency to make changes. Good deal. And then I bring it up for another class, and then I go, oh. Uh-oh, say that one more time?
Yeah, in person class, you just commented that to string.
Oh, you're right. Oh, thank you. Thank you. You're saving me. Because next time I would bring this example up, and I go, why is that, what happened? Oh, I just, sometimes I put stuff in there, and then I forget that I put something in there. So, all right. So we'll do some boring PowerPoint. I shouldn't call it boring. And then we'll, because we're moving on now. That was assignment number 2. So let's take a look at the concept of collections. We'll do a PowerPoint. And then we'll take a break and we'll come back and I'll show you some source code on collections as well. So let's zoom this so I can actually see my screen for a second. Lo and behold, lecture number 6. Collections, using the collections package is equivalent. There's only 20 slides, so don't worry, it's not that long. What we're looking at is a theory that is equivalent to a lot of work in C++ made extremely easy in Java. In C++, if you wanted to create a collection, you don't know what a collection is yet, so let's talk about collection. An example of collection would be a list. And if you wanted to create a list, you'd have to use arrays, and you'd be stuck with array-based implementations. We all know are static limited by static allocations. So if we say array of 5 and we have 6, we have to go back to the drawing board and make the array bigger. Or we can create our own dynamically allocated array, or we can implement what's called a linked list using pointers in C++. And why they never built this into the language, I don't know. But you actually basically have to create a node, and you have to create a list, and you have to create pointers, and a pointer to a list, if you've taken this before, it's a new piece of memory that you're dynamically allocating. This piece of memory knows about the next person next to them, and that person. That new piece of memory knows about that next person and that next person, and that's a singly linked list. And then if you add the reverse direction to it, this person knows about the next person but also knows about the previous person. Then you're looking at a doubly linked list. You're looking at a lot of complex data structures that you have to create by yourself. No help from the compiler, no help from the language that uses pointers. So along came Java. Don't have pointers. A lot of people are like, oh good, no more pointers. And you don't have to do this yourself. We have collections now. And the collections class is part of Java util. And Java util gives us everything. If we want a new linked list, create a new linked list. Create a new queue. Create a new stack. It's actually quite easy compared to everything you've been experienced with so far. So a collection, by concept, is a data structure, actually an object, holds other objects. So it's mentioned in this particular class because it has to do with object orientation. It's object structures that hold objects. And so beyond inheritance, the only thing we really have left is all the special features of objects. Because essentially that's all we have in object-oriented programming is objects, inheriting objects, holding other objects. So when you store and organize objects, it's useful ways for efficient access to those objects, organizes the code. It's kind of like the concept of the array. Instead of having 20 different of the object, you put it all into an array object. We actually have dynamic arrays that we can create that are objects that are not the standard array that you're familiar with so far, hopefully. So check out the Java util package. That's what we're going to check out actually when I show you the source code examples. Lots of interfaces and classes. You're looking at interfaces. Talked about that last time. It's just like an abstract class, but it's an interface class, which means we can include, if we have an abstract class, we can only extend one abstract class. That person abstract class is extended by instructor extends person. It doesn't extend person, comma, animal, comma. Nah. Interfaces, if you remember, allows us to create almost the same concept of the abstract class, but we can implement, and the keyword there is implement instead of extends, multiple interfaces. So the collections are interfaces. So we have a linked list that's really a list implementation. So it implements list, implements array list, implements different types of lists and list concepts. All of them are in a hierarchy, and here's our little hierarchy down on the bottom here. So you implement specific to your own requirements. So you include implementations, and we'll look at the code for this. And here's an overview of the interfaces and the concrete classes and the collection framework. And it's all part of the collection package that you would import, and we'll see that. So the collection has sets and lists. What's the difference between a set and a list? A list is generally ordered, and it usually has one of each kind, or there's a way of getting at the individual items. A set is a belonging to or not belonging to. It's more like, you have a set. What's in the set? Red, white, blue, blue, orange, red, white, yellow. All these things that belong into the set, which is more of a collection. A set is a collection. And the set of all students who are enrolled in this class. And then we have the set of all students who are enrolled in the class next door. And then we can find the union of those and get everybody, or the intercept, and find which students have double enrolled. And have multiple existences because you can't be in two places at the same time. So that would be a set. A list would be, give me the list of all people who showed up today, and like I said, attendance roster list. We have an attendance going around? Okay, good. So we can put your name on the list. We have sorted sets, or tree sorts, hash sets. These are different types. And then the array list, linked list, pretty popular. We're going to focus a lot on the array concept, and your homework assignment number 3 is on the hash set concept, I believe, and the map, perhaps. And the map is another form of collection. Or excuse me, another form of a data structure that is similar to a collection. It runs on the same level as collection. So the collection is the gathering or the grouping of the items. A map is the structure. It could be a hash map, a weak hash map, sorted map. Let's think of a map. Actually think of the map that you would drive in a car, your GPS maps. It's the layout of the order. It's kind of like a list if you think about it, but it's not. It's more of a tree structure in some ways. The iterator. So the iterator is the looping. It's finding items, sorting items, searching items, replacing items. Anytime you have to go through the list and do something to it, you need an iterator. And then the iterator, from the list iterator, would go through the list and sort it alphabetically. Or the iterator is essentially the concept of being able to go through and sort it. Because if we did this manually with linked lists, we have to create, a method to insert, a method to delete, a method to find, a method to sort. Instead, we have create a new object of the iterator, apply it to the collection, use the iterator to go through the collection, let's say the list, and find all of the people with the last name of Hecker or something. So you can sort through that. That's the big picture. That's all we get in the collection framework. We put it together with other little pieces, and we make some sophisticated data structures. Stacks, queues, linked lists. I'm going to show you a bunch of those in a few. Root interface, which is the collection, which is the interface. So methods working with an individual collection. And I say this is the root interfaces because all of the collection items, objects, would have these things. As an example, we normally want to see what size is the set, what size is the list, how many items are on the tree, the size of the branches. Is it empty? Is it full? Does it contain this object? Does it not contain this object? Can we add an object, remove an object? Does it equals hash code to array? Return it out. So, some of these are more specifically implemented on certain types of collections and maybe not so useful for other types of collections. At this point, don't worry about knowing all of the methods. You use the methods. In fact, most people would only use like a handful of all the methods that are available. It's kind of like, do you know all of the system out method calls? People used to print or print line. That's about it. There's like a half a dozen more of them, actually. I don't even know them. To continue. Primary methods operating in the bulk from another collection to, does it contain all, add all, remove all, retain all from this collection versus that collection. Clear, remove the elements from the collection. So the SDD, the Standard Development Kit, does not provide any direct implementations of the collection interface, but the interface gives us our implementation. And we'll see in the examples, we have to add a clear, we have to do a size. If we're using the interface, we're implementing the methods. Then it's basically giving us, and I don't like the word template, but it's sort of giving us a template as to what we need to implement. And most of the actual collection types implement this interface, usually by implementing an extended interface, such as set and list. So we have extended interfaces built on the root interface. And as we go through the extension, just like inheritance, extend one interface from another, we start building. We build the hierarchies, as I mentioned before at the beginning of the class. We lay the foundation down, and then we can start creating instances of higher level objects. Past all the interfaces, past all the abstract classes. Way above all that stuff, we make a new linked list. And linked list is a list, also a collection, has an iterator, has this, has that, and has all these other things included in it as well. So what do we got here? The interface is typically used to pass collections around and manipulate them where maximum generality is desired. Here's our iterator. So the collection interface defines an iterator method. To return an object implemented the iterator interface. So the interface is built, it's implemented. You can access elements in the collection without exposing any of the internal structure. Gives us information hiding. If I said, put all these items in alphabetical order, we don't care what these items are. It just iterates through, or iterate through the items. The items could be numbers, the items could be strings, the items could be objects of some nature. There are no guarantees concerning the order in which the elements are returned. You actually have, because if you think about it, you got a list of numbers, and you got a list of alphabetical characters, and it says, put them in some order. What number or order are you going to put them in? You got to make decisions. So the implementation is too specific for the object that you're creating. So you actually sort of have to go through and use the iterator yourself. It's not as automated as it probably should be, in my opinion. But it's pretty impossible to do that. You'd have to write arrays of string, alpha arrays, and then we would have numeric arrays, and then we would have object arrays, and it would be way too hard to implement every single one of those types of arrays in terms of the objects. 3 defined methods for iterator interfaces. Has next. Does it have any next, or is this the last item? Next and remove. So remove is going to remove an item from the list. Next is going to go to the next one. So an exception will be thrown if there is no next item. Or we can check has next to see if we have a next item before we go to it. And I'll talk about exception handling before this weekend's over as well. So here's a classical routine of using an iterator. So the method that we're going to do is remove the long string, collection col, integer maximum length. So we send a collection, we use it in here, it's going to be called col, and col.iterator, it's going to say run a method iterator, create an iterator it on the collection, and then while it has next, which is, while it has another item in the list, go through and it.remove, which is essentially running a remove method using a has next. We use the same method calls on the same objects that we create that we've used an iterator with. So we create an iterator for the object, use the same method calls to essentially traverse through the object. All the code looks the same after a while. All of your iterators for going through is always going to use a has next, a next here. Get the next one, get the next one, get the next one, remove it, do something to it. Pretty consistent, actually, because all the iterators work the same. So the iteration for the list iterator, slightly different interface. It's the same concept of the iterator. It's a list iterator interface that extends iterator. So it's an extension off of the generic iterator interface. It adds methods to manipulate the order of the list. So the list iterator is a specialization, just the same way as an instructor is a specialization of a person. Actually, it's of an employee, which is a specialization of person. If you follow that hierarchy, it's assignment number 2. So we have some methods: has next, next indexed, previous index, previous next. So we basically added it so we can go through a list of items, one to the other. So when it's at the end of the list, the next index will return a list.size. When it's at the beginning, we're going to get a previous index, will return -1 to say there's nothing, we're going backwards from 0. Remove, add, set, set the list returned by the next or the previous. So, and here's some sample code. Potential problem with the list and the list iterator, they do not provide a snapshot guarantee, which means depending upon how the objects are at any one moment of time, it doesn't guarantee consistent results in terms of the iteration of the list of the object needs to be refreshed. If the content of the collection is modified, this is what I mean by refresh, if it's modified, then the iterator is in use, it can affect the values returned by the method. So that's why I say there's no real refresh, you just have to set the order so they're not both running simultaneously. If you think about this concept of object-oriented programming and objects running in the real time, and we make instances of objects and they have lifetime and they're doing all sorts of things, iterator is also another object. And so it's going to work along with, but it's not necessarily going to know instantly about all the changes that are occurring with the other objects. And if we're looking at a list and we're adding items to a list, taking items away from a list, doing that kind of behavior, the iterator is going to get confused sometimes. That's why I say, after it's all done, after you make all your addition and subtraction, when the list is pretty stable and it's kind of refreshed or it's current, then you run the iterator on it. Just try not to do it simultaneously. Here's an example here. Actually, this is a good example of creating an array list. We import the Java util, and we have a class iterator test. In here, we're creating an array list A that equals a new array list. And then a.add, a.add, a.add. Not bad. Then we have here iterator, it as a.iterator. Created an instance of an iterator, and we added it to A. And then while it has next, we have items in the list. Print out, and we're typecasting this it.next. We're typecasting it to a string or adding it to a string. This is, if you remember casting, you'll have to do this actually in the second assignment. You'll have to treat employees like people in order to get their people ID. Actually, in order to get their name and also their ID information about them that's stored in the person. In some cases, if you want to treat them like a person. Because if you think about the concept, if you're going back to that assignment for 1 second, if you're going through the list of students to find what teachers they belong to, and you've got students and you've got teachers and janitors and everybody in the same thing, if you typecast them all to the same, you can go through all of them, get all of their IDs, or get all of them that are associated, find all the students, and then go through all the students and get their IDs or something. So sometimes it helps to treat an employee or instructor like an employee, or an employee like a person, so that you can work with multiple objects and do the, without any type mismatch errors, essentially, because we still have strong typing in object-oriented version of this. We still have it. It's a strong. Java is actually kind of a strongly typed language, just like C++. So it helps to actually deal with it like types. And here we're going to get an error if we try to take an object that's not specifically converted to a string object, which it is a string object anyway, and we added it to string. Anyway, so if the s equals 1, if it's the number 1, a dot set 2 changed. So here we have some interesting 1, 2 changed. We had them both running, so or, I don't know.
What's it to? A dot set 2 change?
It's trying to tell you that because of the ads are happening, and because this is happening, the timing is off. So essentially, if it equals 1, then a dot set 2 changed.
In second location.
Printed out. I'm sorry?
Second location.
No, this is all for the first one. It's doing both.
Sorry.
What we're doing here is we're going through and we're saying if the item that we've pulled out of the next of the iterator of the list, if the next item is 1, then set the item to 2 changed. So we're printing, we're setting it, well, we didn't see the code for setting it, but assume that we're going to change 1 to 2. And then we're going to print it out down here. But this is going on, and then it's the timing that's creating the interesting output that we're seeing, the 1 and the 2 and the changed. We actually have a 2 in here, too. We have 1, 2, 3. Don't worry about it. Assume that we have multiple running objects simultaneously. We have an iterator running along with the other object, and the adds are happening, and the iteration is happening simultaneously. So the output is not necessarily what you would expect in terms of, is it going to print 1 or is it going to print 2? It didn't get 1. It printed 1. So now it's 1. I'm going to change it to 2. It got 1, but now 1's gone away. So it actually did the 1, it did the 2. It did both, essentially, instead of just 1. Should have just printed out 1. It should have just printed out 2, I should say. But it wasn't in there, maybe. Who knows? It could not have been in there. Because it didn't, if it didn't equal a 1, then why had it print 1? So this, if it equals 1, change it to 2. It shouldn't print 1 on here, but it did print 1. So it's kind of funky output, if you think about it. Don't worry about it. It's just the iterators of logic got messed up. Long story short, do all your stuff at the end, run the iterator to sort while the list isn't changing, while the list isn't being sorted, or while the iterator is not doing something logically that could mess it up. Potential problem with the list iterator continuing. A snapshot will return the elements as they are when the list iterator object was created, which is unchangeable in the future. So we create the list iterator object on the list after we populate the list. Then we get the entire list item. So if we create it before we add stuff to lists, we don't get everything, because it will return the elements as they were at the time that the list iterator object was created. It's kind of like, here's a list of 5 students. Create an iterator. Okay, we got 5. Oh, 2 more added to class. We really have 7 in the list, but the iterator only sees 5 because at the time of the creation of the object, it only had 5. We've lost 2. Well, we didn't lose 2. It's just the iterator needs to be recreated. So we use the iterator with a completely non-changing list that we have. So if you really need a snapshot, you can make a simple copy of the collection. Many of the iterators defined in Java util package are in the type fail-fast iterators. They detect when a collection has been modified and they update themselves. So when the modification is detected, other than the risk performing an action whose behavior may be unsafe, they fail quickly and cleanly throw an exception. So the exception that's thrown is current modification exception, which means you're running a program and you are doing exception handling, I'm going to talk about in the next lecture, and you throw this exception and you catch it. It happens. Then you create a new list iterator. Throw away the old object, create a new one. Refresh it, essentially. So because you've got something in the list iterator that's implemented by the Java util package that says, if it's changed, detect the change. We just can't handle what the change was. And we're not going to update. We're not going to recreate ourselves. Because you can imagine something that just kept continuously resetting. It would be no sense. It wouldn't be able to keep track of anything. And it'd be unpredictable. So here we have an exception that's being thrown. And how does that happen? Because we added 4 after we added 1, 2, and 3. We created the iterator, we added 4, and then we're going to run something on it. And next, and it's going to come back and say, hey, wait a minute. I see 3 items, and you say we have 4. Then we're going to get a current modification exception that comes out of that. So you throw the exception, you catch it, and you take this line of code and put it underneath. Essentially, the exception is going to say iterator IT is equal to a iterator. Create a new iterator. Or you can probably iterator 2 or something. Delete the object or leave the object alone. And good thing for you is that Java's got automatic garbage collection, so you don't have to worry about deleting it. If you're not using it anymore, the collector will come by and pick it up and delete it for you. So let's talk about the concept of a list. A list is an ordered collection, which allows duplicate elements. Its elements indexes range from 0 to the size -1, just like an array, actually. And it adds several methods of an ordered collection. The interface list is implemented by 2 classes, the array list and the linked list. You're wondering, well, why would I want 2? Array list is a little simpler implementation. The sizable array implements, it's a resizable array. So we don't have, when we have an array list, we don't have the same problems we have with an array. An array is not resizable. I create an array of 10 items, it stays as 10 items. This one grows. So adding or removing elements at the end or getting the elements of a specific position is actually, for the O notation, runs fairly efficiently. Adding or removing elements in the middle is more expensive because we have to reorder the array list. Just the same effect that you have if you set an array yourself and you say an array is 50 items and you want to put something in the middle of the list. It's in terms of efficiency, the algorithm runs on the slow side because it's got to go sort everything and change the order of it affects every element in the array. So given the size of the array, it's going to affect your speed. Small arrays, you're not going to notice that much. Big arrays, it has to rotate every one of the items. You're going to sit there and wait for each one of the items to get rotated so you can insert your new item in the middle of the list, which is why I use the linked list. A little easier that way. Can be efficiently scanned by using indices without creating an iterator object. We don't need it. It has the iterator object actually built into it in terms of the functionality of the list. You can go next, next, next. And so it's good for lists which can be scanned frequently. So if we're going to scan the list frequently, we're probably not going to have that big of a list if we're going to scan it frequently. We can use a simple array list, easier abstraction, simple methods, basic functionality. Comes in handy for all sorts of different things. And the same reason why we would use an array. Linked lists. The doubly linked list can go one way or the other. It allows for faster insertion and removal. It's more efficient in terms of putting something in the middle of the list. And if we're not going to iterate through that list too much, we don't have to worry about it. The speed of that array is not going to be too problematic. So, what do we have here? Let's see, getting the elements of position I is more expensive. It's harder to go through it. We don't have a built-in iterator. And it's a good base for lists that most of the actions are not at the end of the list, but they're in the middle of the list. Does this work? Let's see if this link works. Nope, not going to work. I actually have this in an example I'm going to show you in a few minutes. So we don't have to click it now. Oops. Let's see if I can get it. There we go. Okay, sets and sorted sets. So we looked at the array list and the linked list. These are objects that we can create and that all belong to the collection class. Another set is the opposite side of it, not necessarily ordered. So the set interface provides more specific contract for its methods by adding no new methods of its own. A set is a collection that contains unique elements. So a sorted set extends set to specify an additional contract where the iterator on each one of the set always returns the elements in the specified order. So the sorted set gives us sort to the collection versus, or makes it more like a list, I should say, versus the set. And the set in terms of the collection is unique. You remember that part of it. The set of all people with this particular characteristic, or the set of, and just go back to, basic set theory. Boolean, no, actually it's discrete mathematics, I think, actually. So by default, the elements are in the natural order, which is determined by the implementation of the comparable interface. Comparable is giving us our identification. It's giving us one item in the set compared to another item in the set. And it depends on the natural order of the items. That order is unpredictable. We don't know the order. Unless we create an ordered set, then we know the order. An unordered set is just a set. We can't actually get at that information. So you can specify a comparator object in order to order the elements instead of the natural order. So we have another object, sort of like the iterator that we can apply to a list. We have the comparator that can put the set in alphabetical order, can put the set in any type of order that you're specifying in terms of your implementation. Two implementations of sets in the collection framework. We have the hash set and the tree set. Hash set is a set I've implemented using hash table, if you're familiar with that. Don't worry about the data structure background. You don't really need it for this course. Tree set is a sorted set, implements a balanced tree structure, hopefully. And you're using, as an example of using hash set. The example next is going to be, as an example of it using a hash set. I have actually saved the examples for a few because I'm going to show you all of this stuff in a few minutes. The map. This is what you're doing and working with the assignment. In terms of homework assignment number 3. I believe you're using a hash map actually for that. I have to refresh my memory on it after we take a break after this lecture. The map interface does not extend collection. It's a separate one, as we saw before on that first slide of this lecture. The interface between a map contains a key value, sort of like a dictionary. Not only keys, duplicate keys are not allowed on a map. So there's key value pairs, not only just the keys. We have the key and the value that's associated with it in terms of the map. And duplicate keys are not allowed. It's implemented using the hash map and the tree map. So the tree map is going to be this one leads to this one leads to this one leads to this one. It's going to be more of your map of a neighborhood as an example versus a hash map, which is going to be more of a dictionary, database, not a database, but a lookup table, dictionary. So the methods used to view the map of the collection, for example, key set, collection values, give me all the values, give me all the keys, give me all the pairs, which are essentially the specialized method that are going to be placed on the maps. The collections returned by these methods are backed by the map, so removing an element from one of these collections removes the corresponding key value map. So if I said give me all the keys that have the word B, the character B in them, in the name, remove them all. It removes the associated value that goes with the key and vice versa. So it doesn't create problems. We retain the key value relationship. Cannot add elements to these collections. They're sort of statically created. If you iterate through the key and the value sets, then they may return values from their respective sets in any order. There's no order guaranteed. It's just however it's being stored internally. So the interface of the sorted map extends map and maintains its keys in sorted order. Class tree map implements sorted map, as that is the interface sorted map that it implements. Synchronized wrappers and the collections class. So the collections class contains the static utility methods. That's the one we looked at in Java util, which are roughly classified in two different groups, those that are wrapped collections and those that don't. Talk about that for a few seconds. In fact, this part I can probably skip because we don't need this for the purposes. If we were taking a data structures course, learning the Java methods for this would probably be a little bit more sophisticated in terms of what you needed to know. For the purposes of object-oriented programming in Java, knowing about the collections class is important. Knowing about all these intricate details, not so much. So I'm going to fly through this a little bit. But just give you the definitions. We're not going to see any source code examples for wrappers versus no wrappers. All the collections implemented provided are in the Java util that we've seen so far. They are all unsynchronized. Well, we have to think about now threads. So concurrent access to a collection by multiple threads could cause intermediate results or fatal errors. I'll go back to everything you've ever heard about thread and concurrent thread programming and the issues that are associated with synchronization. It's interesting that Java has built-in thread programming. So if we want to synchronize, we just put the keyword synchronize on a method, and it synchronizes it for us. Well, kind of the same thing with the collections. We have the synchronized wrapper that basically says synchronize, so we don't have any communication conflicts between multiple running threads accessing the same collection, which is essentially the theory. So we can use a synchronized wrapper for those collections that might be accessed by multiple threads to prevent potential thread problems. Here's the thing. Add the word synchronize before the method. So if we want to create a map, we create a map. If we want to create a synchronized map, we call the method saying synchronized map, all one word. Which is kind of different because when we synchronize a method, normally at the end of the method we just say synchronized. Synchronize, essentially. And it automatically adds it. So basically the method names in the collection have changed to associate the two sets. One set is synchronized, the other one isn't synchronized. So the wrapper is referring to the synchronized collection instead of collection. So this you don't really need to do for the assignment. And you don't really need to know for this class either. So here's an example, map, unsync map, and new hash map. Look at that. We have collections, a synchronized map that we're going to use here. So we have two of them created. So one of them can be accessed by multiple threads, the other one just by one thread at a time. And the synchronize is essentially going to make the threads cooperate with each other. So merge their activities instead of overwrite what they're doing. And I'm going to skip through, and I never cover this anyway, unmodified wrappers. Nope, let's not worry about that either. And not worry about that one. So you can scratch all the synchronized and the unsynchronized and all the wrapper stuff from your knowledge base unless you're working with thread programming and multiple threads running. You're never going to run into any of the synchronized keywords or any of the methods that would be associated with that. Abstract implementations. So the collection framework provides a set of abstract implementations that we've seen. For your design of your own implementation for relevant collections, interfaces to satisfy your particular needs, a set of abstract classes exist. Abstract collection, abstract set, abstract list, abstract sequential list, and abstract map. And you might notice, in fact, these are the same without the word abstract in front of them. So we can extend and we can use the abstract classes instead of the regular old classes if we want to specialize the implementation. And this is where if you're looking at somebody else's code and it's an abstract set that is being used in your extended class, and then you go look at that and go, oh, what is that? And then you go back to the abstract class. Consider this just the same thing as the abstract person. Instead of actually creating an instance of a list object, we're going to extend from the abstract list, implement it, and create our own list object. That's going to extend the behavior and implement the abstract list concept. Just the same as a person was used as an abstract concept, we're using a list as an abstract concept. And it gives us the, pre-built kind of template, if you want to call it that, or rules, structure, content for what we should put in our list. Just make sure I didn't skip anything important here. Just take a few seconds. Yeah, this is the synchronize and the wrappers. I probably should just pull that out of the lecture. I never really covered anyway. So, legacy collection types. And, all these different versions of Java had different versions of the earlier classes. The ones we have now, the packages that we have now in the current version are pretty nice. We do have some legacy classes. The util package contains other legacy collections than those that we just learned or looked at. They're still a wide use in existing code. Continue to be used by utility programmers shifting over to new types. The enumeration, the vector, the stack, the dictionary, hash table, properties, and we'll see in my examples that I'm going to show you, we can create stacks and queues and lists from collections, from array lists, from linked lists that are already built into the collection. We don't have to use any of those legacy items, essentially. Now it's a good time for a break. How long do we want? 15? It's 11:38. Oh, it's too early for lunch, isn't it? We can take a break, come back, I'll show you the collections, source code stuff, some examples, data structures. Then we'll have lunch break, and then we'll come back and start in with exception handling and other different topics. So go ahead, take a break. 10 minutes? 10 minutes? When everybody gets back, 10 minutes. Okay.